Okay, in this video we're going to talk about two things. We're going to talk about the simple definition of pressure and how that relates to collisions, and then we're also going to take some data down in this section down here and see what it actually means when we're talking about the wall and collisions. So to start, pressure, in a very, very simple sense, pressure is the rate of collisions with the wall of a system. Now, not every system has a clearly defined wall, but in our case right here, we can work with this. We have a clearly defined wall of this system that the particles are all hitting up against. So what this means is the particles here, the pressure is going to go up the more collisions are occurring with the wall, and it's going to be lower pressure when there are less collisions within the wall in this time period. Let's go ahead and take some data, and I'll show you what I mean by this. All right, let's record the pressure of a particular instance. So right now, I have 50 light particles. Sorry, that's not what we want to write. We want to write the pressure that we have right now, which is actually, you can see in that gauge in the top right, 4.9 ATM. Let's see what the number of wall collisions is in this time period. I just hit play there. 38, let's just take that again, see if it's accurate. 43, 39. So 39 was kind of in the middle of those three. I'm going to go with 39 wall collisions in the 5 PS. Let's see what happens if we add another 50 light particles in. Let's record our pressure. We now have a pressure of 9.9 ATM. Pretty much double the last one. And let's record the number of wall collisions. 85, 76, 78, 81. All right, let's go with that last data point, 81, because that was kind of right in the middle of all those. We had a high of 85, a low of 76. All right, that is the number of wall collisions, and it's clearly gone up from the last time. Let's go ahead and see if we can change this again. Let's add in another 50 light particles. Now you can think the more particles that are in there, probably the more collisions are going on. Let's see how many, well, let's record the pressure first. It's 14.8 ATM. And now let's see how many wall collisions are occurring. 127, let's try it again, see what we get. 117, 124, let's go with the middle one again, that last one, 124 wall collisions. Let's take one more. Let's add in a bunch more particles. Let's add 100 more. So now our pressure is 24.7. Let's see what occurs with our wall collisions. 209, 226, 206, 209 was in the middle there, so let's go with that. 209. So as the pressure has increased, it looks like the rate at which our wall is being collided with is also increasing. Remember, this is always over the same time period of 5 PS, which is just a very small amount of time. Okay, so this video has shown you basically that there is a relationship between the amount of collisions occurring between particles in the wall of its system and pressure. When pressure is greater, rate of collisions is greater. And vice versa, when pressure is lower, the rate of collisions is also lower.